Hi, welcome to Karl, Simon. Yeah, here we're finally at the Karl Battery Research Center in Aachen, so where we built up a very specific research center for battery research in Europe. And here we have several chairs and professorships working together, very interdisciplinary research, where we are working on aging, reliability, and lifetime prediction for battery and power electronics. We are working together with several colleagues here. Yeah, Professor Sauer is working in the battery system technology, and Professor Egbert Fickmeier, my colleague, is working mainly on the production, pre-lithiation, and battery materials. And myself is working on a very new topic, which is AI and digitalization for battery technology. So we are developing different digital models to support from battery production further to testing and finally the application in our cars and also stationary energy storage systems. Simon, here we are at the automated testing lab, where we are building a very interesting test bench and methodology to accelerate battery testing. Come with me. As you can see here, Simon, so we have a very important test bench where we are developing automated characterization for end-of-line test and also beginning-of-life test. Here we are using the robotics, right? So to take the cells, to scan the cells, as we have the ID of the cells directly be identified from it, and then track all the information afterwards. And here we are doing electrical tests like characterization, including capacity test, pulse test, and so on, together with impedance measurement. And then we can do thermal imaging also with the same robotics, and then also with the other robotics to take the rollover to do measurement of the CT, so that we can collect information from electrical, thermal, and mechanical information in a very short period. And this is the foundation for our AI approaches, where we are able to use AI to extract information from all the data we collected in a very short term. This will give a very strong feedback to the production partners so that they can further tune their production technology. Yeah, now let's explain the whole procedure. Yeah, you see that we are working with Fraunhofer FFB together, who is producing the battery cells. And the same collaboration is also ongoing with all the other production industry partners in Germany. And here we have this box be transferred to us with the battery cells. Yeah, so I can show you up. So we will get the cells be transferred from our partner.
Thank you.
Yeah, and we will connect the cells in our test bench. And you see that all the other procedures are automated with the robotic. And first we scan the battery cells. And then we can locate it to get the weight of the battery cells. And then we can connect the battery cells automatically and carry out all the electrical tests that we have planned here. So for the electrical tests, we have our AI engineers who is designing the design of experiment with AI to shorten the testing procedure so that we can carry out all the measurements, including electrical, thermal, and CT measurement within 6 hours. So this will shorten the whole procedure significantly, which will finally save time and cost for the production lines.
Okay, so here we got our automation HMI, so human-machine interface. We can select which models we want to execute. Currently, the base measurement is running. We also give the test set a name under which it's saved. And also the species we are using has its own name. So then we tell it which input tray places it's gonna measure. Here it's doing number 1 till number 10 at the moment. And we also give the cells a name. My mouse is not working. And then we just say start, but it's currently running already. That's why we cannot push start. And we can also watch the current data. So here we see the ID was scanned. It's a 5-digit number. And then also now it just measures the weight with 69.35 grams. And that's it.
Yes.
So we got a really fancy transportation system from the robot test bench to the CT. So of course there are more industrialized versions, but we have not a high throughput. So we use the cheapest version that is easy to automate. And as you all know, in Hamburg, automating logs is pretty easy doable. So when a cell is put into the wagon, we can just tell it to go to the city, and then it will just leave. And at the other end, there will be another robot which will take out the cell and put it into the city, and then we can automatically set the measurement.
Simon, here we are at our testing center. So we are operating more than 6,000 channels for battery testing. I think this is one of the largest testing center in the whole world. So what we are doing on this side, so we have several large laboratories. We are doing mass cycling tests. So we are having more than 3,000 channels for like small pouch cells and cylindrical cells to understand how can we accelerate aging in the laboratory and make a faster and accurate prediction of lifetime. And definitely AI is the core of this methodology. As you can see in this lab, we have like more than 700 testing channels. What we are doing is to use all of this testing capacity to investigate how can AI help us in accelerating testing of aging behavior of the battery cells. Come with me, we can show you more details. As you can see, this is one of the several climate chambers. So the role of the climate chamber here is to control the temperature. We have programmed the testing program so that we can also be able to change the temperatures during testing. And here you can see we have all the cells already connected. So the cells are connected with the PCBs, which are also designed by ourselves, by our PhD students. Here we are able to measure the electrical signal and also thermal signal together with the mechanical signal. For example, to measure the deformation of the battery cells. So this 3-dimensional data set are the input for our AI models to do online aging diagnosis, prognosis, and finally accelerate the whole testing procedure. So as you can see here, we are testing different kinds of batteries, different chemistries. LFP, definitely this is one of the important focus, right, for current industry, for automotive and also for stationary energy storage system. And how can we develop a reliable aging model for such new chemistries, which is more and more important for the industry, is our vision. And we are testing different chemistries, different formats. So here you only see the cylindrical cells, but also we are building up the test benches for pouch cells and also prismatic cells. And not only the electrical tests, right, to collect the time series, we also have, for example, devices to measure the impedance very quickly during the whole aging process. And very importantly, I want to highlight the digitalization. So we have worked on digitalization of the testing center for more than 10 years. And now our whole testing center is fully digitalized, which means that we have our own database, our own software developed to collect all the data, no matter from electrical testing or other kind of tests, no matter this is time series data or images. We are developing this new generation of battery testing algorithms for the future battery technology so that we can accelerate testing, so that we can make the testing more intelligent and also carry out virtual testing with AI and machine learning. And finally, we will reduce the cost dramatically for the OEMs and also cell manufacturer. Yeah, for example, Weihan is developing the AI methodology here for battery testing. And what he's doing here is to program the whole process for accelerating the testing to set up and prepare for our testings. Yeah, so this is the daily life of Weihan's research here in our lab. And he's really enjoying the involvement of AI in our future testing methodology. Yeah, Simon, now we are in the chemistry lab. We have the whole floor, the chemistry lab, with all the devices we need to do post-motive analysis. So our goal is not to develop new materials. What we are doing here is to open the battery cells and do different analysis so that we can understand why battery is aging, what has happened, what are the mechanisms. And the whole chemistry lab is led by Professor Fickmeyer and Professor Sauer. And here we are working from my group in the direction of digitalization. We are working together with the colleagues to digitalize the way we are doing post-motive analysis. We are using image-based technology widely in all the research here in Karl. We are working together with Professor Meyer, who is leading the GFE in Aachen University, and all the activities in CT. Together here in Karl, we are working together to use CT and different image-based technology for battery research. And the role for my group is to develop digital models to automate the analysis of CTs and different images. For example, segmentation with computer vision, AI for enhancing the quality of the images, and so on. And here, for example, what we have is a NanoCT, and we can use NanoCT to do very accurate measurement of the battery materials. We also have another MicroCT, which we're using it to measure the internal world of batteries without opening it. Yeah? And also with other technologies like ultrasound and thermal imaging, you see that we have different choices where we can combine mechanical information, thermal information, and together with the time series data to build foundation models with AI for the future lifetime prediction and so on. And this is the core for the future technology.